Hi, in this video I'm going to go through a NMR question that came up in 2014, and it came from you can access it from a link below, but it's question 2 in the Maths and Physics Tutor, or Physics and Maths Tutor, NMR section. So it looks like this. So chemist isolates compound H from a mixture and sends it for initial analysis, showing that the molecular form of compound H is C10H12O. So first bit of info we got is molecular formula. The next thing we know is that, also interesting, always note that the ratio of carbons to hydrogens is almost even. So that normally suggests you've got a benzene ring. But maybe not, but generally that's where I'm going straight away. The carbon NMR spectrum of compound H contains 8 separate peaks. So interesting, again, just told you how many peaks there are. So we've got 8 different carbon environments and 10 carbons. So a few of those are in the same environment. Then the proton NMR spectrum of compound H is shown below. So we've got 5 peaks or 6 peaks, and the part A just asks the proton NMR spectrum contains a peak at delta equal to 0 parts per million, resulting from a chemical added to the sample. State the chemical responsible for this peak and state why this chemical was added to the sample. TMS, or tetramethylsilane, and it's there just to create a standard. So everything else is judged from the TMS. Then, let's have a look at our peaks now then. So, we've got here, I'm just going to label these A, B, C, D and E, and I look at them all individually to see what information each one shows me. So if I start with PK, just put that over to the side. Is it easy enough there? And we can still see it. So A, the chemical shift is 9.6. So I can then go, okay, well, what occurs at 9.6? If I get my data sheet out and have a look, 9.6, the only real thing there is COOH. It could be an OH or an NH. There's no mention of using D2O in here, so they've not tried to remove it if it has. The fact it's a triplet tells me it's not OH or NH, because OH and NH just provide singlets because they're blocking oxygen does. So I know it's not OH and NH, so I'm very confident here that this is going to be an aldehyde environment. Then, what else do I know about it? We can have a look and we can see that it is a triplet. So it's going to have 2 adjacent hydrogens if it's a triplet. And its peak area is 1. So it only has 1 hydrogen, and that makes sense for an aldehyde. An aldehyde group will just have that 1 hydrogen there. So, just very quickly, what I can kind of tell from this is that this environment for pK is going to be my aldehyde. And then I also know that that is going to be next to a carbon with 2 hydrogens on, because it's got 2 adjacent hydrogens. Then we've got peak B. We'll look at B here. You can see B is at 7.1. So again, we can have a look at this. We can see, yeah, so there, 7.1, bang in the middle of a benzene, or OH-NH. Again, because of the multi-peaks, we can rule out OH-NH. So we're going to have here our benzene that I thought we might have when I looked at the formula. Then it's a quartet, often really difficult to tell in benzene that it's whether it's what it's splitting means. This quartet really is difficult to tell. this is the one time actually it's kind of helpful. The fact that it looks kind of even and symmetrical will help me later on. But in benzene, it's very difficult to tell from the splitting. Often it's an absolute mess and really complicated. This is quite an even type of splitting, which suggests that the compound itself is quite even. So I'm leaning towards now that it's going to be in the para position. And it's got 4 hydrogens. So that area equals 4. So what that tells me is that it is going to have 2 bonds coming off it. So then it'll have its 4 hydrogens. So we've got its different hydrogen environments there. And obviously these are difficult to tell with splitting, but because this is nice and even, you can see that each one essentially is adjacent to each other. And that kind of leads us to a quartet. It becomes really complicated in benzene. So C, we've then got, C, it tells us something extra about C. If I turn over the page, so the proton NMR spectrum, the peak at 3.7 parts per million, which is my C, would normally be expected a chemical shift value about 1 part per million to the right, i.e. 2.7. So I'm going to put this down as 2.7. And at 2.7, have a look at my data sheet and go, right, well, it could be a C to an N, but I can rule that out because there's no nitrogen in my formula. It could be a next to a carbonyl, which fits. So it could be that. It could also be this CH. It can't be the OH-NH in this particular one because, again, if we go back, it's a doublet. And we just see a singlet peak. See if I'll focus back in a bit. Focused on my hand a bit too much. So because it's a doublet, it won't be OH or NH. We'd only see singlets for them. So either a carbonyl or next to a carbonyl, which would fit for it being next to that environment at 9.6, or next to the benzene ring, which would fit for it being next to that peak at 7.1. It is a doublet. Out of the way. So it's next to 1 adjacent hydrogen, and its area is 2. So 2 hydrogens. So that fits for this structure here. Next to a CH00, and it has 2 hydrogens. Its adjacent environment only has 1 hydrogen in. So all this fits for that at the moment. We may be off a bit later, but that's what it kind of fits for at the moment. But we're looking at a CH2 here, either next to a COH or on the other side of benzene ring. Either one of those two. Peak D comes at 2.6, I'm going to say, roughly. So D. So again, either the C, it's either next to a carbonyl or next to a benzene ring. It's either this one or this one. It can't be nitrogen because it's got no nitrogen in the molecular formula, and it can't be those because we can see splitting. So it has got a quartet structure. So it's 3 hydrogens adjacent. I don't say that very well. The adjacent environment has 3 hydrogens in it. And so quartet, 3 hydrogens adjacent. Peak area equals 2. So 2 hydrogens just while I remember that, I'm saying that, okay, it's areas 2, so it equals 2 hydrogens. Not necessarily, it's the area tells us the ratio. But I've got 1, 4, 2, 2, 3. So that all adds up to 12, which is the number of hydrogens. If this added up to 6, just for instance, then I'd double it because I've got 12 hydrogens in total. And so the peak areas are all just ratios. But because they all add up to 12, I know that the area is also going to tell me the number of hydrogens. So this is a CH2 as well. And it's either next to a benzene ring or next to a carbon with a carbonyl. And then we have E. Oh, and also next to this is going to be a CH3 group, which kind of rules out a bit that carbonyl idea. So the fact that it's a quartet, it's got 3 hydrogens adjacent to it. Unless, I suppose it could have an aldehyde one side and a CH2 as well on the other side. Then E, we're going to have, it's at 1.2. So that's just our boring sort of alkyl group. It is a triplet. So 2 adjacent hydrogens. And it is free. So area is free. So it is a CH3 group. So 3 hydrogens in it. So that kind of fits for this. But at the moment, we know it's a CH3. We know it's not going to be next to anything fancy. So this CH3 is not going to be bonded to a benzene ring. It's not going to be bonded to a carbonyl. It's not going to be bonded to, that was it, wasn't it, that we've really seen so far. So it's just going to be bonded to a CH2, so 2 adjacent hydrogens. So there are 5 peaks. We'll start to put these together a little bit now. So a bit more space. I'm running out of room. So I know that PK was an aldehyde. And we know that peak B was a benzene ring. And that it had 2 bonds coming off it because there's only 4 hydrogens in total. So it could be para, meta or ortho. The way we'll tell the difference later on is to look at the carbon NMR spec because it told us how many were in the carbon. So it could be any of those 3. Because it's nice and symmetrical, the splitting, I'm leading to it at the moment being this one, but we'll be able to tell with the carbon NMR. So we've got A, B. C was either, we could have had 2, we kind of narrowed it down to for C. It was either a CH2 group off a benzene ring, or it was a CH2 next to an aldehyde. This fit better at the moment if we go, because it was C was adjacent to just 1 hydrogen, and that fits for this at the moment. That is just 1 hydrogen adjacent, so I'm leading towards that one. D then is either, again, the same again, it was either this or this again. So this is what we saw at D. That was at 2.6. So it's either of these 2. It's quartet. So there were 3 hydrogens adjacent. And its area only had 2 hydrogens in. So either of these could fit. The thing I'm looking at here is this would have to be CH2. Sorry, no, it was it's a quartet. So next to it, you'd have to have either a CH3 here, or if it's this one, a CH2 there. Yeah. That fits. So that'll give a quartet, that'll give a quartet. Then E was just our CH3, which was next to a CH2. So I'm just going to rub this side bit out. So I've identified my 5 peaks now, A, B, C, D, and E. And now it's a case of putting it all together. So there's only one aldehyde peak. Our overall formula was C10H12O. So only C or D can be next to the aldehyde. So I'm going to stick with C at the moment because this, I had to kind of fudge this a bit to get it to fit. So I'm just going to try this with COH, and that's pK, next to peak C, which should be CH2. So I've just combined A and C, and I can see that. There, that fits. pK was a triplet, and that would fit at the moment for pK. Peak C was a doublet, so that fits at the moment as long as whatever's bonded here doesn't have any hydrogens on its environment. B is my benzene ring, so I'm going to have a benzene ring in there somewhere. And now D, I'm going to cancel this one out. It can't be this one, because we've already got the oxygen used, and there's only one oxygen. So I'm going to say that's out there. Then D, so it must be onto a benzene ring with then a CH3 attached, which is going to be my E. So I'm going to have a CH2 CH3 group, and then my benzene ring needs to be attached twice. So either of these two are going to get attached to a benzene ring. That will give peak D the right peak at 2.7 because it's attached to a benzene ring. CH3 would fit, and all the splitting would fit as well then. So let's try and put this together, because the final bit is to then look at the carbon NMR and the different environments. So we could have I should just draw skeletal to save myself time, really. It in the ortho position. Or in the meta. Or in the para. So ethyl group, aldehyde group. So what we need to do is look at the different carbon environments we've got now. It told us in the question that there are 8 separate peaks. So this one would have 1, 2, 3, 4, 5, 6, 7, 8. So that actually fits there for the meta. No, ortho, sorry. Let's check that. 1, 2, 3, 4, 5, 6, 7, 8. Because my instinct was it's going to be this one, but it doesn't look like it will be. So that works. And here we've got 1, 2, 3, 4, 5, 6, 7. Ah, I've miscounted carbons. This is why. This is not a deliberate mistake. Sorry. You may have been screaming at me to count up to 10 in a benzene ring. 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again. They're all going to be different. And then in this one, 1, 2, 3, 4, 5. But these environments are going to be the same because they're bonded to exactly the same things. We've got a nice mirror plane. 7, 7, 8. So 8 environments in this one. This isn't a mirror plane in this one, just in case you're thinking if it was to go down there, because on this side we've got an E file. So this environment is going to be different to this carbon here, because on that side it's got the aldehyde group on the side. Same thing over here, although we could draw a line down here. Because these two groups aren't the same, carbon on this side is going to be different from this side. But in this one, it doesn't matter that these are different because they're in the plane. And so this carbon and this carbon are going to be the same. So this will be the correct structure and that you need. And that was worth, I don't know how many marks that was worth. A total of 10 marks, including the TMS bits, and 9 marks. But most of it would have been for doing that work on the peaks and kind of putting in all the info for the peaks.